Hey, so I know this video might be pretty long, but before I get into it, I just want to say, everything I'm going to do is in full detail, full explanation, trying to make sure that, if you know nothing about it, that hopefully by the end of the video, if you watch the whole thing, you'll know everything about it, okay? So I know it takes some time. It takes some time out of my day to make it, but I know it's going to help you guys prepare for the test. So starting with number 1, we're going to solve each system using any method that we want. Now, looking at number 1, the first thing I notice about it is the first equation, we have y completely by itself. Y is equal to 6x minus 11. Now, say, for instance, that it was y equal to a number like 3. Well, what if it was y equals 3? Well, what you would do, right, is you would plug in 3. You know that y is equal to 3, so you would just plug in 3. It works the same way, even though it's not a number, okay? Y equals, not 3, but y equals 6x minus 11. But we can still take this whole chunk and we can still plug it in for y. This is called the substitution method because we're substituting in 6x minus 11 in place of y. So how that works is we'll still have this whole equation written. We'll still have negative 2x. There, we'll have minus 3. But where y was, right, we used to have negative 3 times y. Instead of having y, we're going to replace it with 6x minus 11. Okay? And then it's still the rest of the equation still equals negative 7. So just so you can see this, right, negative 2x minus 3. I'm going to put y there, but I'm going to put it in a separate color just so you can kind of understand how substitution method's playing out, right? I'm writing down the exact same equation that I started with, but you can see that I've substituted what y was with the 6x minus 11. Because now I have an equation here that has no y in it whatsoever. I only have x's in it. So that means that I can now solve this equation. I can figure out what x is. So going in through that process, we're going to first distribute, because we have negative 3 being multiplied with what used to be y. So negative 3 is being multiplied with 6x and negative 11. So we're going to go ahead and do that first. Negative 3 times 6x makes negative 18x, and negative 3 times negative 11. Remember, you're multiplying here. Negative 3 times negative 11 makes a positive 33. Everything else, the negative 7, I'm going to bring down. The negative 2x, I'm going to bring down. Now, I notice as well that I've got these 2 x terms on the left side. I can put these x terms together. Why have 2 x terms when I can just have 1 x term, So negative 2x minus 18x is going to make us negative 20x. Bring down everything else. Again, all I did was just simplify those x terms. So bring down 33, bring down negative 7, and just continue to solve. So our goal, remember, is to get x by itself. So we're trying to cancel out the 33. We're trying to cancel out the negative 20. So we'll start by canceling out the 33, right? The opposite of positive 33 is subtracting 33, right? So that gets rid of it. 33 minus 33 is 0. So now we get negative 20x equal to negative 40. Oops, almost wrote the wrong thing. Negative 40. And now, because negative 20 is getting multiplied with x, the opposite of multiplying is dividing. So we're going to divide negative 20. That way it'll cancel out. We'll have x equal to positive 2. Now, keep in mind that every solution is an ordered pair, an XY ordered pair. So we have the x value, but we still don't have the y value. But don't freak out, because even though it took us that long to get the x value, it's rather simple to get the y value. If you look back at the original equation, it could be either one of these, by the way. It doesn't matter which of the 2 equations, but we're going to look at this first one, just because, remember, the y is already by itself, so it's going to be easier to plug into. So take that equation, right? And now that you know x is equal to 2, just substitute 2 in. Just plug 2 in for x. So we'll take that out. We'll plug 2 in. So now we just evaluate for y. Y is equal to 12 minus 11, because 6 times 2 makes 12, and 12 minus 11 is 1. So y is equal to 1. So the answer for that is 2, 1. All right, number 2. So apologize, I'm going to have to erase some of this just so I have room for number 2, but that's fine. You guys can always pause the screen, okay? You don't have to go, oh, he erased it, because you literally could just rewind it. All right, number 2. I'm looking at number 2, and what I notice is that the x here's are aligned, the y's are aligned, equal signs, these numbers, everything's lined up, because that's a good idea if we want to use the elimination method. Elimination method works in the sense that you add the two equations together, you add the x terms together, you add the y terms together, and you add these numbers together. But the purpose behind adding them together is to cancel one of those variables out. Either cancel out the x's or cancel out the y's. Now looking at this, the y's could cancel out potentially, but not quite. Because right now if I add these equations together, negative 2y and minus 2y is actually going to make negative 4y. They don't actually cancel out. So what would be nice is if I could make one of them a positive 2y, doesn't matter which one, because a positive 2y with a negative 2y would then cancel out. So that's what I'm thinking about. So I'm looking, it doesn't matter which one you want to try to make positive, could be the first, could be the second. I'm going to go ahead and make the second equation a positive 2y. Now, how am I going to do that? How am I going to change this negative 2y into a positive 2y? Well, I can't just change the sign, you know? It's not that simple. I have to figure out what can I multiply negative 2 by to make it that. And that's how all these problems will work. What can you multiply it by to make that change? So what can I multiply negative 2 by to make it a positive 2? And the answer to that is a negative 1. If you do negative 1 times negative 2, it'll make a positive 2. So knowing that, I'm going to multiply this entire equation by negative 1. I have to do the entire equation because otherwise, you know, these other terms won't keep their balance, right? I can't just change one part of the equation and think it's going to be exactly the same. So I have to do it to all three of those terms. And that's fine. You know, it'll change these two terms here, but it doesn't matter. You know, what we're trying to really focus on is trying to change this to positive 2y because then it can cancel out with the negative 2y. So let's rewrite the equations. I'm not going to change the first equation at all because I want to keep it as negative 2y. But when I multiply the second equation by negative 1, I change it to positive 7x, a positive 2y, and a positive 13. So I multiplied every single term by negative 1 and written down the result. So now I can actually add the equations together because what's going to happen is the y's are going to cancel out. They're going to be eliminated. That's the whole purpose of this method. X plus 7x is going to make 8x. Negative 2y plus 2y, like I said, that's 0y. That's going to cancel out. And then 11 plus 13 makes 24. So now all we have is the equation 8x equal to 24, and we just need to solve this. And it's a rather simple one-step process. We just need to divide by 8, and x is equal to 3. Just like on the last problem, remember, though, our answer is an ordered pair, so we still have to figure out what the y value is. So just like the last problem as well, you can pick either equation, doesn't matter which one, okay, and then plug in the 3 for x. You can plug it in for that x, you can plug it in for that x, doesn't make a difference. Pick one and I'll work it out. So I'm going to pick the first equation. The first equation is x minus 2y equals 11. So I'm substituting out the x and plugging 3 in instead. So when I evaluate, I'll subtract 3 because it's a positive 3. That leaves me negative 2y equal to 8. And then I'll divide by negative 2. And I have y equal to negative 4. So that's solution for number 2. Number 3, let me erase this. Number 3, I'm also going to use the elimination method on because I notice, again, the x's are aligned, the y's are aligned. Everything is in line here. So all you got to do is just add the equations together. But remember, you don't add anything together until you'll have x's or y's cancel out. So negative 5x does not cancel with 3x. 1y does not cancel with negative 8y. So we have to do some work, kind of like we did in the last problem. So it takes a little bit of creative thinking, but let's try, it doesn't really matter which one we try to cancel, but let's say we try to cancel out the x's. Okay, so you're looking at these two numbers and you're thinking, okay, they're not alike, but how can I make them alike? What can I multiply negative 5 by? What can I multiply 3 by so that they could eventually be the same number? Now to do that, you have to come up with a common multiple of 5 and 3. What's a number that 5 can be multiplied and make? what's a number that 3 can be multiplied by and make? And both of them can make 15, right? If I multiply the first equation by a 3, I can make it 15. If I multiply the second equation by 5, I can make it 15. So I can make these both 15x. Now again, I need one of them to be a positive 15x, the other to be a negative 15x for them to cancel out. Now the first equation is already negative, and the second equation is already positive, so let's keep them that way. Let's just multiply the first equation by a positive 3, because what will happen is 3 times negative 5 will make that number negative 15. Now, keep in mind, the other terms, they're going to change as well. They're going to be multiplied by 3, and they're going to be affected. And that's okay. Don't worry about that. Just worry about your goal of trying to make this a 15x. So if I make that top equation negative 15x, then I'm going to make the bottom equation positive 15x. So 3x, to make it 15x, I have to multiply it by 5. Now, yes, I'm going to multiply every term there by 5. But what my goal is, I know the numbers are going to change here, and that's fine. But the goal is at least I'll have 15x in that equation. So let me show you what happens now when we multiply these equations out. So multiplying the first equation by 3 times negative 5 is going to make negative 15x. Again, we made that a goal of ours. That's there. But we have to do 3 times the y as well, which makes 3y. And we have to do 3 times the negative 3, which is going to make it negative 9. So that's the first equation. That's the exact same thing as the first equation, except everything there is multiplied by 3. Now the second equation, we're multiplying everything by 5. So 5 times 3x is going to make 15x. 5 times negative 8y will make negative 40y. And 5 times 24 makes 120. Now, it looks different, but that equation is, again, exactly the same as this equation, just everything was multiplied by 5. Now, the reason I've done that is so now, look, if I add the equations together, guess what? The x's are going to cancel out, right? Negative 15x plus 15x is 0x, and it'll disappear, leaving me with just the y. So 3 minus 40 will make negative 37y, and negative 9 plus 120 makes 111. So all I got to do is evaluate and solve this problem. Just got to get the y by itself. So since it's negative 37 times y, I can get rid of it by dividing by negative 37. That gives me y equal to 111 divided by negative 37, which makes negative 3. So now that I know y is negative 3, just like before, I can plug that in to y. It doesn't matter which equation, but plug it in for y and solve for x. So I'm going to plug it in the first one. So if I do that, let me erase this just so I have some room. Right, if I plug in the first equation, I get negative 5x plus y equals negative 3. But again, I'm replacing that with negative 3. So the opposite of minus 3 is going to be adding 3. That'll cancel it out. Add 3 as well to that side. You have 5x, negative 5x equals to negative 3 plus 3, which is 0. And then negative 5 times x, right? So we got to divide by negative 5 in order to cancel it out. So that leaves us x equal to 0. 0 divided by negative 5 is still going to be 0. So we got our y value. Y value was negative 3. And our x value was 0. So now we just got one more. We just got to solve number 4. Now number 4, I see that it's aligned, but I also notice that the y's are equal to each other. Or not equal to each other, but I have y by itself, right? And both of these. So I think it's going to be a little easier if I try to use substitution method. So notice that y is equal to 3x minus 4, right? Y is equal to this information. So just like I did on the first example, I'm going to take this and I'm going to plug it in to the y in the other equation. So you see right now I've got the equation y equal to negative 6x plus 14. But I'm going to plug this 3x minus 4 in for y. So when I do that, I'm going to have 3x minus 4 equal to negative 6x plus 14, right? Y used to be here, but now I've replaced y with 3x minus 4 because I'm just plugging this in to that y. Okay? So now I just got to solve this equation. So when I do that, I'm going to kind of combine my x terms. So I see this negative 6x, and I'm going to try and cancel it out. So the opposite of minus 6x is plus 6x. So I'm going to cancel out the entire term, and I'm going to make sure I add it to this side as well. So what that's going to leave me is 3x plus 6x is going to be 9x. Minus 4 is still going to be there. And then on the right-hand side, it's going to just be the 14. And I just solved this. So I'm going to add 4. I'll have 9x equal to 18. And then when I divide by 9, I'll have x equal to 2. So I know the x value is 2. So now I just got to plug that in to find y. So I'm going to plug it back into the first equation. You'll notice that equation here. So I'm going to plug 2 in for x because that's what x equals. X is equal to 2. So that's going to be 3 times 2, which makes 6. Minus 4. 6 minus 4 is 2. So the y value is also 2 here. My answer is 2, 2. All right. That's it for the first 4 problems. Those problems are definitely going to be the ones that take the most time. The rest of these won't take nearly as long. That's probably about half the video right there, just those 4 problems. All right, number 5. You don't really have to do a whole lot of work. It's going to be like 3 seconds. The graph is already shown. What's the solution? Well, the solution, we have 2 functions. We have a function here, we have a function here. You don't have to worry about the coordinate plane. The coordinate plane's a coordinate plane. We don't really care about it. We're just looking at these lines here, the graphs, the functions. You'll notice that they cross at this intersection point right there. That's our solution. The solution is where they cross. We just have to identify what that order pair is. So if I number this number line, it'll make a little more sense. But remember, this is my y-axis, this is my x-axis. So on the x-axis, it's at -2. And on the y-axis, it's at +2. So the order pair of where those lines cross is at that point, -2, +2. That's the answer. Number 6 is the exact same thing. Notice where these 2 functions cross. They both cross right here. You just have to identify that order pair. So on the x-axis, it's at 1 on the x-axis. And on the y-axis, it doesn't go up or down, right? It's at 0 on the y-axis. So the answer is just the point 1, 0. All right, that's it for number 6. Number 7 and 8. So we don't actually have to solve the system by, from scratch. We have a solution, right? Or at least what is pretending to be a solution, right? It's our job to identify whether that solution is correct or not. So it's basically just checking someone else's work. Hey, you know what? Here's the system, and here's what we think the answer is. Will you check it for us? So that's what we're going to do. Now keep in mind that 2 is the x value, the 5 is the y value. So to see that it works, to see if it is the solution, all we need to do is plug those values in. Plug the 2 in for x, plug the 5 in for y. Okay, and just evaluate it and see if we get equal to 7 and equal to -11. And if we do, then yes, it's a solution. If we don't, then it's not. So the first equation is x plus y equal to 7. But remember, I'm plugging in 2 for x, and I'm plugging in 5 for y. And I'm just going to see if this works. Well, 2 plus 5 is 7, and 7 does equal 7. So that's good. The first equation checks out. But I have to check both equations. The system is made up of 2 equations. It's no good if it works in one and not the other. So I have to make sure, I have to check the other equation as well just to make sure it works in both. If it doesn't work in this one, then the answer is no, it doesn't work overall. So I have to make sure that it's in there too before I verify, say yes. So we're going to plug the 2 in for x. So remember, we have 2 times x minus 3 times y equal -11. But I'm plugging 2 in for x, and I'm plugging in 5 in for y. So let's evaluate. This becomes 4. This becomes -15 equal -11. 4 minus 15 is -11. So -11 equals to -11. This is true, which means overall that point works. 2, 5 belongs. It fits in both equations. So the answer here is yes. Make sure you show your work though, okay, like I did. Same idea with this one, right? -2 is the x, 0 is the y. So we're just going to plug those numbers in and see if they make sense. See if they work. So the first equation is y equals -2x minus 4. But I'm going to plug in 0 for y, and I'm going to plug in -2 for x. So when I do that, I have 0 equal to negative 2 times negative 2 makes positive 4 minus 4. 4 minus 4 is 0, so it works in that equation, which is good to know. Now let's check the second one. Second equation is y equals x plus 4. So we're going to plug in 0 for y, and we're going to plug negative 2 in for x. So now I've got 0 equals negative 2 plus 4. Negative 2 plus 4 is positive 2. And 0 does not equal positive 2, right? This isn't true. That's a false statement. So it doesn't actually work in the second equation. So it works in the first one, but it doesn't work in the second one. So therefore, it's not the solution. Okay, we are not working out the system. Keep in mind, we didn't actually solve the system at all. I was just plugging in the point that I was given to see if that point is the solution or if it's not. And that's all I needed to do. And that's what I've done. That's my answer. Okay, number 9, graphing. So when we're graphing it, we have to have an equation set up in this format. It's called slope-intercept form. Now, the reason why this is useful is because whatever value I have here for m, whatever number that is that's my slope. It tells me my rise and my run. It tells me where the points are going to go on my graph. And then the b value right here, b is called the y-intercept. Therefore, the name slope-intercept form, right? The y-intercept, now this just tells me where my first point is going to go on my graph. So if our equation is already in this format, then I can just take that information and graph it. I don't have to do any math. I just have to simply apply it to the graph. Now, one of these equations is already in that form. The second equation is already in that form. We have the y equals the 1/2 acts as my m, and the negative 7 acts as my b. Okay, so that's the information that I'm looking at when I'm graphing. Now remember, the y-intercept, the b value, which in this case is my negative 7, is my starting point. So I'm looking at the y-axis, which is the one that goes up and down, and I'm going to start at negative 7, which is right here. Okay, so I put my point there. Now I use the slope to tell me where all the other points are going to go. Now the slope of this line is negative 1/2. Now what I like to do is I just apply the negative to the top number. You can apply it to the bottom if you wanted, but it's easier for me if I apply the negative to the top. So really think of this negative 1/2 as really negative 1/2. So our slope, remember, is rise over run. So it's telling us to rise negative 1 and then run 2. So from my starting point, we're going to follow these directions. Now, if it's rising 1, that means I'm actually falling, right? It means I'm actually going to go down 1 unit, down to negative 8. And then I have to run 2, and I'm always going to run to the right, a positive direction. So I'm going to run to the right 2, which puts my next point right here. And I continue following that pattern to fill out all the other points. I continue to go down 1 and right 2 to get my next point. Now I've run out of room. So it's still a straight line, right? The line's still supposed to be straight. So what I'm going to do is I'm going to repeat the pattern that I did here, but in the opposite direction. So to do that, I'm going to just do the opposite of what I did. Remember, I went down 1 and right 2? Well, I'll now just go up 1 and left 2, and I'll get the points in the opposite direction. So up 1, left 2, up 1, left 2. So there you can see all my points, and I'm just going to put a line between them. So that's the graph of that second line. That is y equals negative 1/2 x minus 7. But we still need to graph the other line, right? Y minus 2x equals 3. Now the problem is it looks like it's almost a slope-intercept form, but it's really not, right? It's supposed to be y equals mx plus b, and it's y minus right now, right? We don't have the y equals. What we need is we got to move the negative 2x to this side. Now, in order to do that, in order to put it on the opposite side of the equation, we have to do the opposite operation. So since it's minus 2x, we have to add 2x in order to cancel it out here and then move it on to the other side. So that leaves us with y equals to 3 plus 2x, which I'm going to rewrite as y equals 2x plus 3. These are exactly the same thing based on the commutative property, which means I can add things in whatever order I want. The reason I did this is because some people make mistakes if they leave it written the original way, and it's easier for us if we write it as, mx plus b. If it looks like that, it's still right if you have it in the original format. It's just kind of backwards, right? Because the 3 is still going to be your b value, and then 2 is still going to be your m value. But sometimes that confuses people when it's written backwards. Okay. So now we're going to graph this line. So remember, the b value is where we start. So this b value is a positive 3. So on the y-axis, I'm going to go find positive 3, which is right here. And that's where my first point's going to go. Now, 2 represents my slope. Now remember, I like my slope as a fraction. I like to know that what my rise is and what my run is. But my slope here is just 2. So what I want to do is write 2 as a fraction. 2 is the same thing as 2 over 1. Now this helps because now I know that my rise is 2 and my run is 1. So from my starting point, I'm going to follow this direction. I'm going to rise 2 and I'm going to run to the right 1, which puts my point right here. Now I don't have any more room to go up 2 and right 1 anymore, so I have to continue now going backwards. So instead of going up 2 and right 1, I'm going to follow the same trend but backwards. Down 2, left 1. That puts me here. Down 2, left 1 puts me here. Down 2, left 1 puts me here. Down 2, left 1 puts me here. And you can see how that continues to fill out. Let me erase my little lines. And there's your line. Now, it's just like numbers 5 and 6, right? You see the graph. You just got to say where they cross. Well, they're crossing right there. So that's our answer. That point, if we draw it out, that's -4 on the x-axis and -5 on the y-axis. So the answer to this is -4, -5. Okay, number 10. Verizon and AT&T are selling a new iPhone. Verizon offers a new iPhone for $550 plus $40 per month. AT&T offers a new iPhone for $450 plus $45 per month. Okay, in how many months would the cost be? Would cost for the iPhone be the same for both companies? So what I want to do is write an expression for both these. Verizon is $550 plus $40 per month. So for Verizon, it's $550 plus $40 per month. So 40M. AT&T is $450 plus $45 per month. So $450 plus $45 per month. Now, in order to find out when the cost is the same, right? Same. That means equals. All I'm going to do is take the two expressions, set them equal to each other. That's Verizon equaling AT&T. So when I solve this, I'm going to find out, I'll be getting the M value for when Verizon is equal to AT&T. So there's our set equal to each other, and now I'm going to just go ahead and solve. So I'm going to subtract 40M to start with, just so I can cancel 40M out and move it over here. So that's going to leave 550 equal to 450 plus 5M, because 45 minus 40 is 5, right? So now I'm solving for M, so I'm going to try and cancel out the 450 and then also cancel out the 5, just so that M can be by itself. Canceling out 450 means subtracting 450, right? 450 minus 450 is going to cancel out, and we're going to move it over here. So now that's going to be 100 equals to 5M. So to cancel out the 5, I'll have to divide by 5. So I'll divide by 5 to cancel it out there, and 100 divided by 5 simplifies into 20. So my answer is 20 months. 20 months, both phones will cost the same amount. All right. Now number 11. Number 11 and number 12 are very, very, very similar. Pretty much the exact same thing we did in the first 4 problems. So if you know how to do those problems, if you remember how to do them, you can do number 11 and 12. Trying to scroll down. Let me scroll down. There we go. I'm going to work them out. If you feel like you know how to do them, then you can just stop the video here. I would still, you still have to work them out though, so you might as well just watch this through and fill this out. But here we go. Substitution method. Remember, the substitution method means plugging it in. Now you'll notice that the second equation has y already by itself. Y is equal to negative 5x minus 17. Remember, when we started the video, I said, okay, what if just pretend, right, it was y equal to a number, like y equal to 8. Right? If it was y equal to 8, then you would just plug 8 in for y, and you would go about solving your problem. But it's not a number, it's an expression, but it doesn't mean we don't still do the same thing. We're still going to plug this in for y. So let's write that whole equation out. We have negative 3x minus 3 times y equal to 3, correct? Now remember, we're plugging this in for y. So the rest of the equation is not going to change. All we're doing is putting negative 5x minus 17 in to replace y. So where the y used to be, I'm going to take out, and I'm going to write negative 5x minus 17. Let me make that look a little bit better. There we go. And I keep accidentally erasing stuff, but there it goes, equals 3. So you see, it's the exact same thing as the original equation. It's just y has been replaced with negative 5x minus 17 because that's what y was equal to. Okay, so now there's no y in this equation. Now we can just solve this equation. So the first thing I'm going to do is I'm going to distribute my negative 3 to both terms. So negative 3 times negative 5 is going to make a positive 15x. And negative 3 times negative 17 makes 51, positive 51. I'm going to bring everything else down. Bring the negative 3x down. And since it's positive 15, by the way, it's now going to be plus 15x, not minus 15x. The negative here canceled out when I multiplied it with the negative 5. I'm going to bring down my equals 3. I notice I've got two x terms here that I can combine. Negative 3 plus 15 is 12x plus 51 equals 3. So when I solve this, I'll subtract 51. I know it's kind of hard to see. I'm getting kind of running over the letters there. So we have 12x equal to negative 48, and then just divide by 12. We have x equal to negative 4. But keep in mind, it's not the final answer, right? That's only the x value. You still have to plug this in to find the y value. But it's easier now. Because you know that x is negative 4, you can just plug negative 4 in for x. So it doesn't matter which equation. You can plug it into the first equation as well. But it's going to be easier to plug in the second one since y is already by itself in the second equation. So y is equal to negative 5x minus 17. But remember, I'm taking out x. I'm plugging in negative 4. So this becomes y equals to 20 minus 17, which is 3. So y is equal to 3. So there's your final answer, point negative 4, 3. Now we have one more problem to solve using the elimination method. Now remember, the elimination method works when you just add up the terms together. Add the x together, add the y's together, add the numbers at the end together. But you can only do that if you're going to cancel out the x or the y. So we can't do it yet because this would be 8x, this would be negative 4y, and this would be 22. It doesn't really matter what that last part is. But notice, I did not cancel out y. It's still here. I did not cancel out x. It's still here. So we can't add them together the way they're written. We have to make some modifications. So there's a couple things that I can do. I notice I could multiply the first equation by 3. Now, if I did that, notice 3 times 2 would become 6x. Well, actually, I could multiply it by negative 3. Because if I did that, negative 3 times 2 would be a negative 6x, which then I know would cancel out with that positive 6x. So that's one possibility. Another possibility is, to cancel out the y's, if I multiply the top equation by 5, then this is going to become 5y, which would cancel out with negative 5y. So I can do either of those things. I can multiply it by negative 3 if I want to cancel out the x's, or I can multiply it by 5 if I want to cancel out the y's. So it doesn't really matter which one we pick, right? Let's pick the x's. Let's multiply by negative 3, and we'll cancel out the x's. Keep in mind that that number is going to get multiplied to all the terms here, so not just the first one. So that whole equation now becomes negative 6x minus 3y equal to negative 60. Negative 3 gets multiplied to all three of those terms. Okay, now I'm going to keep the second equation exactly the same because it already has a 6x here that's going to cancel out with the negative 6x that I just made. So bringing it all over, it's 6x minus 5y equal to 12. So now I can add the equations together because negative 6x plus 6x will become 0x, therefore eliminating, canceling out. But with the y's, I'll have -3 minus 5, which makes -8y. And then -16 plus 12 is going to be -48. All right, so I just divide by -8, and I'll have my y. Y is going to be equal to +6. So I know that 6 is my y value. Now I just got to plug it in and find x. So it doesn't matter which y I plug 6 into, as long as I just, plug it in and solve for x. But I'll pick the first equation. So 2x plus y equals 20. But I'm going to plug in 6 for y, because remember, y is equal to 6. And I'm going to solve. So I'll subtract 6. That's going to be 2x equal to 14. And then I'm going to divide by 2. I'll have x equal to 7. My answer there is 7, 6. That's it for the video. I really hope it helps. I spent some time doing this just for you guys so that you guys are prepared for your test. Good luck on it. Let me know if you have any other questions. Just message me on Remind, or just ask me in class. Send me an email, whatever you got to do, okay? Let me know. All right. I'll see you guys later. Good luck on your tests.